Draw the structure of the monomer from which polymer A is made. So this is quite simple. The only difference is we put double bonds in two of the carbon backbone atoms, and the rest of the structure is same. Okay. B. The formula C4H10 represents two different structural isomers. 1. What is meant by the term structural isomers? So whenever we have double bonds in a structure, the double bonds can be in different positions. So whenever we have the same number of atoms in a compound, but we have different positions of the double bond, those substances are known as structural isomers. So we can have this as substances with same molecular formula, since the number of atoms in the compound will always be the same. The only difference will be the position of double bond. Okay. Part 2. Draw the structure of two structural isomers with the formula C4H10. Show all of the atoms and bonds. Okay. So we have butane over here. We can write the first structure we can draw as a straight chain butane with 10 hydrogen atoms and 4 carbon atoms. Alright. Now the second structure which we can form is we can have a methyl group with this the second carbon atom, and then we can have all of the rest of our hydrogen in the same place as we had in the previous structure. So we have the same number of hydrogen and carbons, but the only difference is that we have changed the position of this methyl group. Okay. Part 3. All structural isomers of butane are flammable. Write a chemical equation for the incomplete combustion of butane. Okay. So in incomplete combustion, we have the products as water and carbon monoxide instead of carbon dioxide, and we need to balance this here. You can write 2 over here, A9 over here, 8 and 10. So we have 20 hydrogen atoms on both sides and 18 oxygen atoms with 4 2 4s are 8 carbon atoms. Alright, moving on to question number 6. Dilute hydrochloric acid reacts with aqueous sodium carbonate. The chemical equation for the reaction is shown. A 25 cm cube portion of sodium carbonate was placed in a conical flask with a few drops of a suitable indicator. It was titrated against hydrochloric acid of concentration 0.18 mole per dm cube. 20 cm cube of hydrochloric acid was required to reach the end point. Calculate the concentration of sodium hydroxide in mole per dm cube using the following steps. Okay, so calculate the number of moles of hydrogen chloride used. We can use the formula moles is equal to concentration into volume over here, but over here we're supposed to convert this 0.18 mole per dm cube to mole per centimeter cube, since we have the volume as 20. So we do so what we do is we divide 0.18 with 1000, and then we multiply this with the volume, which is 20, and this gives us the number of moles as 0.036 moles. 0036. Okay. Okay. Calculate the number of moles of sodium carbonate contained in the 25 centimeter cube portion of sodium carbonate. So for sodium carbonate, we only have the volume, and we do not have the concentration. However, we can use the equation to deduce the number of moles. As we can see in the question, 2 moles of hydrochloric acid react with 1 sodium carbonate, which means we're supposed to with 0.036 moles of hydrochloric acid, we'll have half the number of moles of sodium carbonate, which is half the number of 0.036 is 0.0081, sorry, 0.0018. Calculate the concentration of sodium carbonate in mole per dm cube. So now we have the number of moles and the volume over here. To calculate the concentration, we divide the number of moles with the volume over here, but when we get the answer, we're going to have to multiply it with 1000 to convert it into mole per dm cube. So we'll have it as 0.0018, which is the number of moles, and then we divide it with 25, which is the volume, and multiplying it all with 1000 to convert into mole per dm cube, and this gives us the concentration as 0.072 mole per dm cube. B. In another experiment, the volume of carbon dioxide produced was 48 dm cube, measured at room temperature and pressure. How many moles of carbon dioxide in this? Okay, so we have the volume, and we're only supposed to divide it with molar volume, which of any gas is 24. So when we divide 48 with 24, we get the answer as, but here we are supposed to first convert centimeter cube into dm cube. So we can divide it with 24 dm cube, which is the standard unit. So when we divide this with 1000, we get the answer as 0.048, and then we divide this 0.048 with 24 dm cube, so we get the answer as 0.002 mole. Okay, C. A sample of concentrated hydrobromic acid was electrolyzed using platinum electrodes. The concentration of hydrobromic acid was 8.89 mole per dm cube. Calculate the concentration of hydrobromic acid in gram per dm cube. Okay, here we're supposed to convert the number of moles to the mass, and to calculate the mass, we're supposed to multiply the number of moles with the molar mass. So in that case, we need to find the molar mass of hydrobromic acid. Okay, so starting with the molar mass, we have hydrogen as molar atomic mass of hydrogen as 1. Then we add the atomic mass of bromine, which is 80. So we get the mass, molecular mass as 81. and then we multiply this with the number of moles over here, which is 8.89. So we get the answer as 720.09, but when we round it we get 720, and so we have the mass over here. Okay, part 2, explain why concentrated hydrobromic acid can conduct electricity. So in the liquid form or aqueous form, we have the separate ions of hydrogen and bromide in the form of liquid, so they can move around and they can carry charge. Okay. Part 3, magnesium is not a suitable metal from which to make the electrodes. Explain why. So magnesium is a reactive metal, so whichever product that we have can react with magnesium. Part 4, predict the product formed at the anode when concentrated hydrogen bromide is electrolyzed. Okay, so anode is the positive electrode, and which means it is supposed to attract the ion of opposite charge, since opposites attract. So over here we have hydrogen ion as plus charge and bromide ion as the negative charge. So we'll have bromine, which will be attracted towards anode. So the product here will be bromine gas. Part 5, write the ionic half equation for the reaction occurring at the cathode. So cathode is going to be attracting hydrogen, with positive attracting towards negative. So we have our ionic equation in this form. Okay, as you can see, hydrogen always exists in the form of diatomic molecules. So to have two atoms of hydrogen on the product side, we're supposed to have two hydrogen atoms, two hydrogen ions on the reactant side. And then we have a plus charge of plus one charge for each hydrogen atom, and to cancel out two of those charges we need two electrons. So this is why we have the equation as such. Question number 7. This question is about ethanol. Ethanol that is suitable for use as a fuel can be manufactured from sugars such as glucose C6H12O6 by a two-step process. Describe how this can be done. In your answer, include an equation for the reaction in which ethanol is formed. The second bullet asks the essential conditions for the reaction in which ethanol is formed. And the last one is the name of the process used to obtain ethanol that is pure enough to be used as a fuel from the reaction mixture. Alright, starting with the equation, this is fermentation of glucose. So that means the equation is going to be glucose, which is C6H12O6, fermenting to form carbon dioxide and ethanol, C2H5 and OH. And we need to balance this equation with a 2 on both of the products. So glucose ferments and forms carbon dioxide along with ethanol. The second one is essential conditions for the reaction in which ethanol is formed. Since this is an anaerobic reaction, it does not require, in fact, it requires absence of oxygen. So that is one of the requirements. So as you can see over here, this question is of 5 marks, which means 1 mark for the equation, 1 mark for the name of the process, and since these conditions is plural, that means it has to be at least 3 points to gain all of the rest of the 3 marks from 5. So here I have written one of the conditions. The other requirement is presence of yeast. So yeast is also required along with a temperature higher than 30 degrees Celsius. So these are the 3 requirements, and now name the process used to obtain ethanol that is pure enough to use as a fuel from the reaction mixture. So ethanol formed and the reaction mixture are both in liquid form, and that means separating liquid from liquid is requires the process of fractional distillation. B. The equation for the complete combustion of ethanol is shown. Use the bond energies in the table to calculate the energy in kilojoule per mole for the complete combustion of ethanol. Okay, so energy needed to break bonds is the energy given used on the reactant side. So we'll be using the energy for all of these bonds. So as we can see over here, we have 5 bonds between carbon and hydrogen, a single bond between carbon and carbon with a single bond between carbon and oxygen and hydrogen, and then we have 3 double bonds. Actually, we have a single diatomic. We have 3 diatomic molecules of oxygen, each of which having double bonds. So let's start with calculating the energy between carbon and hydrogen atoms. So we multiply 5 with the carbon and hydrogen atoms energy, gives us 403. And then we have the carbon to carbon bond, which is a single bond, so we can simply write 347. And then we have carbon to oxygen, which is 358. And then we have oxygen and hydrogen, which is 464. And last one is the 3 diatomic molecules of oxygen. So we have 3 into double bond energy is 498. So when we add all of these, we get the answer as 4728. Okay, so this is the energy required to break all of these bonds on the reactant sides, and energy released when bonds are formed is the energy which comes out when all of these bonds form, that is on the product side. So we over here we can see in the original compound of carbon dioxide we have 2 double bonds between carbon and oxygen, but since we have 2 molecules of carbon dioxide, we now have 4 double bonds between carbon and oxygen. So we'll start with this one. 4 times the carbon and oxygen double bond, which is 805. And then we have in a single water molecule we have 2 bonds between hydrogen and oxygen, but since we have 3 molecules of water, we now have 6 bonds between hydrogen and oxygen. So we multiply 6 with 464, which is the bond energy. So 6 into 464. And now the sum of this all is 6004. The energy change for the complete combustion of ethanol is we get this when we subtract the energy released from the energy needed. So 4728, then we subtract the energy given out, and this gives us the resultant energy as negative 1276 kilojoules per moles. Alright, part C. Ethanol can be oxidized by hydrogen peroxide to form ethanol. A catalyst for the reaction is the ion of iron. What is meant by the term catalyst? So it is any substance which is used to speed up a reaction but is not used up by the reaction, that is, it remains intact by the end of the reaction. So alright, part 2. The structure of ethanol is shown. Complete the dot and cross diagram to show the electron arrangement in a molecule of ethanol. Show outer shell electrons only. Okay, so I'll start with using dots for hydrogen and cross for carbon. So we have only one electron in each shell of hydrogen, so it needs another electron which carbon is going to be sharing with hydrogen, 3 hydrogen atoms. This one. Alright. Okay, so now this carbon, each carbon has 4 electrons in its outer shell, 3 of which are used with 3 hydrogen atoms, and the last one is going to be used in this bond between these 2 carbon atoms. And now this carbon atom is supposed to be left with 2 carbon atoms, and those 2 carbon atoms are going to be used with a double bond between this oxygen atom. Sorry. So we have 2 carbon atoms, right? So I'm going to be using an O for oxygen as well. So oxygen is left with 4 of its atoms since it only has 6 electrons in its outer shell. Alright, that's it. All of the atoms have complete outer shells. The table gives the boiling points of ethanol and ethanol in terms of attractive forces between particles. Suggest why ethanol has a lower boiling point than ethanol. So a lower boiling point simply means a lower the forces of attraction between molecules is weak. So means okay, part D. Ethane gas reacts with steam to form gaseous ethanol. The reaction can reach a position of equilibrium. The forward reaction is exothermic, which means the energy is given out or heat is given out. So part 1, state and explain the effect of increasing the pressure on the position of equilibrium. All other conditions are changed. Alright, so when the pressure is increased, the number of collisions increases and the forward reaction becomes faster, and that is because on the reactant sides we have greater number of molecules. We have 2 moles over here, 2 different moles over here. However, on the product side we only have 1 mole. So the number of collisions increases on both sides, but the increase on the reactant side is greater. So the forward reaction increases and hence the position of equilibrium shifts to right. So alright. Part 2. Increasing the pressure of a gas increases its concentration. State and explain the effect of increasing the pressure on the rate of reaction. All other conditions are unchanged. So whenever we increase the pressure, the volume becomes less. That means the number of collisions per unit area increases, and that is the reason that rate of reaction increases. So increases. Okay. Part 3. State and explain the effect of increasing the temperature on the position of equilibrium. All other conditions are unchanged. Okay. So increasing the temperature. As we know, the forward reaction is exothermic, which means by increasing the temperature, the forward reaction will be increasing, since that is endothermic. We need more energy for the backward reaction. So we can say that equilibrium shifts to left. Alright, we're done with this paper.